Hello, hello. So, in this video, we're going to begin the topic or the chapter covering quadratic graphs and equations. We'll define what that is and what that means and how the graph changes. But this will be the final thing that we have to cover for intermediate algebra. So, kind of exciting. So our EQ is what are the key components of the graph of a quadratic function. So the first thing we're going to do is define what that word quadratic means. And a quadratic function basically means it has to have x squared in it. Okay. We spent a lot of time talking about linear functions, which are, y equals mx plus b, where it had an x, but it didn't have x squared. So in order to be a quadratic function, a lot of times it's going to look like this, where a, b, and c will be replaced with numbers. So for instance, I could have x squared plus 7x plus 11, dogs in the background. So this would be an example of a quadratic equation. Another example of a quadratic could be y equals, let's do 2x squared plus 9, where the middle term, the bx is missing. So it's possible that it can only have two terms, but in order to be quadratic, it has to have x squared. So everything that we do, you will see x squared in there. Sometimes it'll only be x squared, which we'll look at in a second. Sometimes it'll have other stuff afterwards as well. This is called standard form, what I just showed here. This is the standard form of a quadratic, where it's the x squared first, and then the plain x second, and then finally it can end with a plain number like 11. So that's a quadratic function. We're gonna start by looking at the graph of the most simple quadratic function, and that is just y equals x squared. Okay. In order to be quadratic, it has to have x squared, but it doesn't have to have anything else. So what this rule tells us is that the y-coordinate is simply, to get the y-coordinate, all you have to do is take the x-coordinate and square it, which means to multiply it by itself. So if x is -2, I'm going to do -2 times -2, which would give me 4. So the y-coordinate that goes with -2 would be 4. With -1, if I do -1 times -1, that's +1. 0 times 0 is 0. 1 times 1 is +1. 2 times 2 is +4. So if I were to take those 5 points, so for instance, -2, 4, okay, and I were to graph that, that's right there, and then -1, 1 would be right there, 0, 0, 1, 1, and 2, 4. So a couple things that you can see about this graph is it is not a straight line, because the points kind of almost make a V shape. But what's important to see here is that this point right here is not in a straight line with these other 2 points. Okay, so please don't just do this. That's not what the shape of this graph looks like. It comes down, flattens out for a brief second, and then goes back up. And this graph will continue going up and up, because if you use numbers bigger or outside, like -3, -4, or +3, +4, we would see that the graph keeps going in both directions. So this shape is what's called a parabola. You've probably heard of it before. So the entire shape is called a parabola. There's a couple different pieces to this. The point in this case, at the bottom of the graph, where it kind of flattens out and then it starts to go back up, that is called the vertex. We also have, and we'll mention this briefly as we go through, this is what we call the line of symmetry. It's a line that if I were to cut the parabola exactly in half, it would fold up on itself. So this is the line of symmetry. But that's just some of the language that you'll see as we go through chapter 9 and the things we have to cover. So the shape is a parabola. The vertex is the most important point, and that's the point that's either at the bottom or sometimes you'll see it's at the top of the graph. And then there's also a line of symmetry that goes through the vertex as well. Okay. What are the most important parts of a quadratic function? We already discussed it. Going to move on. So, how do I find the vertex? Again, the vertex you should be able to visually spot pretty easily because it's either going to, in this case, occur at the bottom of the graph down here. So here's my vertex of that graph. And if I look, the vertex is a very specific spot on the graph. So we're going to write it out as coordinates. So that point right there, that vertex, if this is 0, 0 in the bottom middle of the graph, that vertex is at 0, 4. And the second question we're going to talk about with this is the vertex a maximum or a minimum? And with regards to that, we're talking vertically. So is the vertex at the bottom of the graph, which would be a minimum, or is the vertex at the top of the graph, which would be a maximum? This one is clearly at the bottom of the graph, so this is a minimum. Okay, so that's kind of that parabola is what we say. We say this one is opening up because it's going upwards. And then this other parabola we see is going the opposite direction. So this is continuing off the page in a downward direction. So I call that opening down. And here the vertex is actually at the top of the parabola. And the coordinates of that vertex, again, you have to make sure you find 0, 0. That would be 2, -3 for that vertex. And that particular vertex is a maximum. Okay, so the vertex can be either a max or a min, and we're going to figure out in this video how I know whether it's going to be a maximum or a minimum. So basically what I have here are 4 quadratic functions or quadratic equations, and we're going to figure out which one is the narrowest and which one is the widest. Now, in order to do this, I'm going to use Desmos to help me out here. If you haven't used Desmos before, it's an awesome resource and tool. I know there's Desmos already up here, but there's something else I want to do with that in a minute. So I have 4 graphs: y equals 2x squared. Then I have y equals 0.5x squared. So you see already that they are very much shaped differently. Okay, the 2x squared graph is taller and skinnier, and then the 0.5x squared is a little bit wider. The next one we had is negative 0.4x squared. And finally, I have negative 2.5x squared. I didn't put the y equals, but Desmos knows that that's what I'm talking about. So if we look at these 4 graphs, which one is the narrowest and which one is the widest? The widest one, and it's not by much, but the widest one is this green parabola. It's a little bit wider than the blue one. So the widest would be negative 0.4x squared. So if I scoot back to the iPad, so I have the widest would be y equals negative 0.4x squared. And then right after that would be y equals 0.5x squared. If we go back to the go back here one more time. It's kind of tough to see, but this red graph, the 2x to the second power, is definitely narrower than blue and green, but the purple one is even a little bit more narrow. It's even more compacted side to side. So that means that my narrowest graph is that 2.5x squared, or negative 2.5x squared. And you may see a pattern here already. As far as being narrow or wide, that is determined based on the number in front of x squared. Okay, what we call the a value. So the width of the parabola, how wide the parabola is affected by the value of a. Okay, where as a gets close to 0, Now, what's important here is that it doesn't matter whether it's positive or negative. The closer a is to 0, the wider the graph is going to be, and the farther from 0 that the value is, the graph gets narrower or skinnier. Okay, and that's why I wanted to use Desmos to show this real quick. In this other tab right now, the a value, see it just says a. Right now, a is 1. Okay, but if I move this slider to 2, what's happening is that this graph, as you could see, the graph got narrower. There's 1x squared, there's 2x squared. So it definitely got narrower. And as I go closer to 0, you see that the parabola is widening out. Now, your a value will never be 0, because if the a value is completely 0, then it goes flat, because 0 times anything is 0, and so we don't really have to worry about that. But if I go negative, what we see is the same rule applies. The further you get from 0, the narrower it gets. But now the shape of the graph has changed. Instead of being opening up like that happy smiling face, this is opening down, or like the frowning face. But that rule is the closer to 0 you are, the wider the graph is. The further from 0, the more narrow the graph is going to be. Okay, so the a value tells us whether it's narrower or wide based on the number. Okay, and then from what we just saw, it's fair to assume, and if I go back here, and we don't have to assume anything, we can see which which graphs opened up. Well, the ones that opened up are red and blue, which are 2x squared and 0.5x squared, and the ones that opened down are the negative 0.4 and the negative 2.5. So if I go back here, which ones are opening up? That would be 2x squared and 0.5x squared. That's a 0.5. And then the ones that are opening down are negative 2.5x squared and negative 0.4x squared. Okay, so you probably can jump to that conclusion already, is that the parabola is going to open up or down also based on the value of a. The parabola opens up if a is positive. But what's interesting about that is if the a value is positive, okay, the vertex is at the bottom of the graph. So the vertex is a minimum. And how this throws students off sometimes is when you think positive, you automatically think maximum. Your brain thinks up for positive. And the graph opens up, but because the graph opens up, that means the vertex is at the bottom of the graph. So the vertex is a minimum. Okay. And this will always be the case if the a value is positive. And then the flip side of that statement is if the a value is negative, any negative number, the parabola is going to open down, so it's going to be kind of this sad face, okay, where it continues down in both directions, and those eyes are a little crazy. And then the vertex is actually at the top of the graph. So the vertex is a maximum. So when it comes to the a value, it actually tells us a lot about the parabola. It tells us wide or narrow, and it also tells us is it opening up or is it open down instead. Okay, so what is changing the a value change? It changes width versus narrow, and it also changes opens up versus opens down. This is basically going to act as the summary for this video. What doesn't change, and this is important, is that through this, as we've been changing the a value, making the graph skinnier and narrower, one thing that didn't change, and Desmos is kind of cool because you can animate this, is one thing that's not changing is I thought I could speed it up. One thing that's not changing is where the vertex is at. Notice that the vertex is at 0, 0 the entire time. Okay, and that's really important because the vertex is the most important point on a parabola, and the fact that the a value doesn't change where the vertex is at, it will be important later on. Okay, so what it doesn't change is it doesn't change the location of the vertex. It also doesn't change the line of symmetry. Again, we're not going to talk a ton about the line of symmetry, but the line of symmetry is just that line that splits the parabola right in half. Okay, so wide versus narrow and open up versus open down is what the a value dictates. I'm not going to do a summary. The previous slide can act as the summary, and that's the key piece to